Okay, in this video we're going to have a look at the force equals mass times acceleration equation, the F equals ma. So let's get straight into it. Alright, so this is the formula here, and it's always provided to you if you're doing NCEA Level 1 Science. It's provided to you. It'll be on the front cover or on a separate sheet or in a little box at the start of the exam. And one way, somewhere it'll be provided to you along with a whole bunch of other formula. So what is it saying? Well, it's here we've got force. So F stands for force, and we've just got to remind ourselves the unit for force here is newtons. So all our values should have a big N on the end. M here, little m, is for mass, and so the unit for that is kilogram, is our standard unit. And acceleration, the A here is acceleration, and its unit is meters per second per second. So we usually show that as a little ms, both lowercase, with a little -2 at the top. Now we'll have a look at this unit a little bit more closely when we do a video on acceleration and some graphs and things like that to do with acceleration. So for now, force equals mass times acceleration. Now we've actually already kind of touched on this idea, believe it or not. We looked at forces and we said that if a force is unbalanced, if we've got a net force, it will make an object accelerate. And we said, actually, we mentioned that as kind of newtons in our last video, or one of the previous videos, that this was Newton's second law, that the rate at which an object accelerates is proportionate to the net force on it. Well, we left one thing out, and that was the mass here. So what we essentially said was, basically if I double the force, if I push on an object twice as hard, it will accelerate or speed up twice as quickly. If you think about this in terms of maths, in terms of this equal sign here, if I double this number, or if I double the f on this side, I'll double the value on this side, the total on this side. So it makes sense. The equal sign is showing that they're proportionate to. Doubling the force will give me double the acceleration, assuming the mass stays the same. Or doubling the acceleration will give me double the force. They go hand in hand. Or they're proportionate to one another. Now, we said this was Newton's second law. Now, Newton's second law is essentially this equation. So, Newton's second law is the relationship between an object's mass, its acceleration, and the applied force is force equals mass times acceleration. So, he essentially said that the rate at which an object accelerates is proportionate to its mass, to the force applied, but its mass kind of plays a role in here too, and we'll look at that a little bit more closely. But to start off, you may find it useful to learn the formula or learn how to put it into this triangle format. Lots of students find this easier to remember, easier to manipulate the formula here. Now the triangle is really just a way for us to rearrange the equation. So if we look at the original equation we had, we said force equals mass times acceleration, so we can just write that ma. If we want to rearrange it, well, we can do maths, and if you're good at algebra, you'll know, well, we can divide by acceleration on this side, and that means we can divide by, I'll do it like this, divide by acceleration on that side. If I divide it on both sides, it means I effectively get rid of this a here, and I have the acceleration on the other side over here. So this way now I've got a formula, and I could swap them around, so that I've got m equals force divided by acceleration. Or I could rearrange it. Let me just clear that. I could rearrange it if I wanted the acceleration. If I wanted the acceleration, so let's start with our original formula, force equals mass times, I'll put in the times this time, acceleration. If I want the acceleration, well, I could divide by the mass on this side, divide by mass on this side, and that way I effectively get rid of the mass, and so acceleration is equal to force divided by mass. So this is how we can rearrange our equation. But some students will find it a lot easier simply to learn it or use a triangle like this. essentially what we do when we use a triangle like this, you put your finger, or you cover up the one you want, the one you're trying to work out. So if we're trying to find the force, we put our finger over force, and then you look at the remaining two values. So if we are trying to work out the force, we put our finger on that, and we're left with M and A, mass and acceleration, and they're both down here next to each other. So we can then write out our formula. We can say, well, if we cover up F is equal to mass times acceleration. So we assume there's like a little times in here. Alright, if we want the mass, we can say it is equal to force divided by acceleration. So the mass here, if I cover this one up with my finger, alright, I'm left with force divided by acceleration. So mass is equal to force divided by acceleration. Right, and lastly, we can do we can also do, if I want acceleration, acceleration is equal to force divided by mass. So we've got acceleration is equal to force, the force applied, divided by the mass of the object. So these triangles are really helpful, or some students find them really useful, because you can cover up one letter with your finger or your thumb, and if that's the one you're trying to work out, and it gives you kind of an indication of what the other two values are. Now, one thing to be aware of, if you've got any formula that has just sort of three variables to it, what you can do is, if it starts with whatever format it's given to you in, if it's written like this, then it'll always be the first letter, the first variable that's going to go on the top of the triangle. So if it's all in a line like that, if it's something equals something times something, so F equals MA, it's going to be this first value that goes on the top of the triangle. Now, if it were given to you in a different format, for instance like this, acceleration equals force divided by mass, it's always the value that's on top that goes in the top of the triangle. So if you look at your formula, you can basically go, whatever value's on top goes in the top of your triangle, and if none of them are on top, then it's the first one that goes in the top of the triangle. So that's one way, because you're going to be given the formula, that's one way you can always work out what the triangle is based on the formula you're given. Alright, anyway, let's get into it and have a look at a couple of sort of problems. Well, actually, we'll start with just some few conceptual problems before we do any calculations. If you look at these two shopping trolleys here, if I apply a force to both of them, the same sized force to both of them, which one will accelerate more quickly and why? Well, essentially we come back to, we need that formula. So if I ask you, if I push both of these with the same force, which one's going to accelerate faster and why? We're really asking, we can use this formula. Now, we'll start with it as the F equals MA. And I'll rearrange it. So I'm asking you what's happening to the acceleration. So we'll rearrange it to acceleration equals force divided by mass. Okay, so if I apply the same force, okay, so the force is the same, why am I going to get a different acceleration for these two shopping trolleys? Well, the answer basically is because they have a different mass. If the shopping trolley is full, of your groceries, this mass is going to be a lot bigger. So let's pretend the force, for instance, is 10 newtons. And the shopping trolley here, let's say it's got 100 kg. Now that's probably a bit unrealistic, but let's say it's really full of a whole lot of heavy items. Let's say it's 100 kg. Well, then my acceleration is only going to be 0.1, and it would be meters per second per second. Sorry, I got cut off there for the unit. Now my shopping trolley down here, the acceleration, well, if the force is the same, So we're still maybe pushing it with 10 newtons, which is not a lot of force. If we're pushing it with 10 newtons, maybe this one that's empty is only 10 kg. So straight away you can see that, oh, lost the bottom of the G there. Straight away you can see that this is going to be one accelerated at 1 meter per second per second. So the gist of this really is, if we look at these formula, if we look at our formula here, acceleration equals force times mass. And in NCEA they do like to sometimes ask these questions where they want you to explain the formula in words rather than doing any calculation. Now feel free to do what, in that situation, to do what I've done, to make up some numbers and say, well, if this one weighed this much and this one weighed, so you can see a difference there. But essentially what you want to be able to do is say, well, look, the acceleration is equal to force divided by mass. If I make the force, if I make that value bigger, I'm going to get a bigger acceleration. But with a formula like this, if I make the bottom value, the mass, bigger, what happens to my acceleration? Well, it's actually less, it's lower. So in any formula like this, increasing the top value gives us a bigger value, and increasing the bottom value here actually gives us a smaller resultant value. So the acceleration here, increasing the force gives us a bigger acceleration, increasing the mass actually gives us a smaller acceleration. So we can say the force is proportionate to the acceleration, but it's inversely proportionate for the mass. So giving us a bigger F, giving us a bigger force would make it accelerate faster. So our two trolleys here, if we wanted it to accelerate faster, we could either give it a bigger push, a bigger force, or we could, empty it, so the lighter it is, the less mass, the quicker it's going to go to. And you can imagine these two trolleys here. If we gave them both a shove, well, giving them a bigger shove, giving them a bigger force would make them accelerate faster, they'd speed up faster. But also, you can imagine if we gave both of these trolleys a decent shove, well, this one down here, the empty one's going to speed up a lot quicker than the top one up there. Alright, on to our next example. So you could even get a question which is as simple as why is it so hard, or why is it that when you push a car that it accelerates or speeds up so slowly? Well, essentially there's a limit to how much force our poor guy over here can put in. So we said, acceleration equals force divided by mass, and it's because the mass of the car here is so big that our acceleration is going to be a relatively small value. So basically here, because our mass of the car is so heavy, given our force, it's going to accelerate fairly slowly, because whatever force we put in, it's going to be divided by that massive, that large mass of the car. And you could imagine if we were pushing a truck that weighed twice as much, it's going to accelerate twice as slowly. It's going to accelerate even more slowly. Or you could say for a truck, to get it to accelerate at the same rate, we'd need twice the force, because it's got twice that mass. If we had twice the force, we would still get the same acceleration. So it is quite useful, or you're going to need to be able to kind of explain these formula in words a little bit to answer some of these questions. So, I mean, the key to doing that is just recognizing that if you've got a formula like this, increasing the top value, sort of doubling F here, would double acceleration. Whereas the bottom value, the value underneath, if we double the mass here, we're actually going to half the acceleration. So it has the opposite effect. Okay, so on to finally, I've got a question from an NCEA paper. Right, so we can try and answer that. A boy runs along a track as shown above. During section Y, he runs with a constant acceleration of 0.2 meters per second per second. Calculate the net force acting on the boy. He has a mass of 60 kgs during section Y. Give an appropriate unit with your answer. So a little bit of a tip or some advice here as to the way I would tackle this problem. I always write down the values that have been given to me and the value I'm looking for. So they've told me the mass, so I'll put m equals, I've got 60 kg. Alright, and then they've given me the acceleration. The acceleration is 0.2. Sorry, that A is a bit weird. Sorry, I'm cutting it. That's getting a bit cut off, isn't it? So they've given us the mass is 60 kg. They've given us the acceleration is 0.2 meters per second. Oh, sorry. Meters per second, and we want to work out the force. And this is quite useful if you jot this down, because A, it means you don't have to reread the question to find the information as you go, but also straight away you'll notice these are the three factors I have. It's going to help you pick out which formula you need to use. So in this case we're going to use our force equals mass times acceleration triangle. So I do my triangle there and I cut off the force. Okay, and by the way, it doesn't matter which way around the bottom two values go in the triangle. You just got to remember which one goes up the top. So anyway, to work out the force, we've got force equals mass times acceleration. And in this case, that is 60 kg times 0.2. Now, it is, guys, you really have to show your formula, your working, and then you want the answer and your unit. So 60 times 0.2 is 12. I can do that in my head. You're allowed to use a calculator. Alright, is 12. Now, what's our unit? So remember, it's force, so it must be newtons. So the answer here is 12 newtons. Alright, so hopefully that made sense. It's a fairly basic problem. They often tie this together with other sort of things. But a good way to approach a problem like this, use your triangle. So write down what values you've been given, what value you're actually trying to work out. Write down the formula, show the working, the answer, and the unit. And one big issue sometimes is a student might even know how to do this, and they'll just put down 12. They'll get straight to the answer and they'll just throw down 12. And you go, there might be 4 marks for this. There might be one for the formula, one for the working, one for the unit, and only one for the answer. So if you just give the answer as a number, you may not actually even pass the question. Cool. I hope you found that helpful.